And for this, I want you to have the table 9.7 available on page 393, and also go to page 413 and take a look at the flowchart. If you want to take a picture and have that next to you when you're answering this question, that will be great. For this question, you need to complete the reaction, and you also need to identify the reaction as SN1, SN2, E1, or E2. And I would advise you to follow the flow chart, this flow chart. Okay, so the first step that you need to do to answer these type of questions is to decide what type of haloalkane that you have. So in this example, we have a tertiary haloalkane, and then take a look at the nucleophile that you have. This is a weak nucleophile, okay, and it's also a polar protic solvent. So let's follow the flowchart. We are looking at this row here because this is a tertiary haloalkane, and because of that, then we can rule out the SN2. Let's answer the question. Is the nucleophile base a strong base? The answer for that is no. Then let's answer the next question. Is the solvent polar protic? Yes, the solvent in this case is ethanol. And by the way, on the exam, you may see this ethanol as just with the line formula, or you may see it as having ETOH. Whenever you see that ET, that means that you have two carbons, 1 and 2. So be familiar with either way. So ethanol is a polar protic solvent, so the answer to this question is yes. So because of this, it says substitution and or elimination product via fast SN1 and E1. So you will have both happening, but it says that the SN1 may dominate over the E1. So just put both, and you can put major for the SN1. The major product will be the SN1, the substitution product. So how this looks like for the substitution, you will substitute this halogen with your nucleophile, but without the H, just this section here. Okay, so 1 and 2. Okay, let's take a look at your E1 product. That is the elimination. This is the SN1 product for the elimination. You will take this away, and then you will put a double bond. So this is for the E1. And just in case you forgot from the class, whenever you see that triangle here, that means heat. Let's take a look at the next question, 14C. Okay, the first thing you have to do when you are looking at completing a reaction and also knowing what type of mechanism it will take place, then decide the type of haloalkane that you have here. This is a secondary haloalkane. Then take a look at the pKa, or the conjugated acid of this base, to see if you have a strong base or you have a weak base. This base is the acetate base, so the conjugated acid is acetic acid. And the pKa of acetic acid is about 4.7. And because it's far below pKa of 11, then it is considered to be a weak base. So the base of that conjugate acid it is a weak base. And because it's a weak base, there will be little to no elimination product due to the E2 reaction mechanism. If you take a look at table 9.7, you will see that the acetate ion is considered to be a moderate nucleophile. And because of this, then we could do the prediction that your SN2 will be the major product. How does the acetate ion looks like? It looks like this. So that is your nucleophile. What you will do, again, we are doing the SN2 reaction. You will take this halogen and you will replace it with the nucleophile. So oxygen, and then that. And again, you may get a little bit of the elimination product, but the major product is predicted to be the one coming from the SN2 mechanism. All right, let's take a look at 14D. Okay, we need to complete the reaction, and we also need to know if it's SN1, SN2, E2, or E1. The first step is to identify what type of haloalkane you have, and that is a secondary haloalkane in this case. Then take a look at the pKa, or the conjugated acid of the base. So what is the base in this case is this ion, and what is the conjugated acid is HCN, and the pKa of this acid is 9.3. And because of this is slightly below 11, this base is considered to be a moderate to weak base. However, this ion is a really good nucleophile. It's a good nucleophile. And because of this, the SN2 will dominate over the E2. You may not see the elimination product, and if you do get the elimination, it will be in very small amounts. So we get the SN2. Again, substitution, you will replace the halogen with your nucleophile. Count your carbons, 1, 2, 3, 4. And 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. And then you will put the CN. However, for SN2, we get the inversion of configuration due to the backside attack of the nucleophile. So instead of coming from the front, it will be now at the back. And this is a solvent, DMF, and this solvent is a polar aprotic solvent, and that helps out the SN2 reactions.